Hi there everyone, this week we're going to learn DC circuit. So you should log on to Canvas, click on modules. Once you click on modules, you scroll down, you will click on the DC circuit PDF file, and then the data can be, and I'm going to upload the recording to this subfolder. Lab instructions subfolder, and then the data can be you can retrieve the data from the lab data subfolder, the DC circuit data, which will be released published when it's ready. Okay, all right. So let me bring up the file. So the file, once you open it, is this. So the purpose of this experiment is to become familiar with the circuit board, and also how to use voltmeters, and also learn the characteristics of DC circuit. So this is basically, if you were in the lab, you'll be given this electronic board. So let's just get familiar with some of the components on this board. So these two are the battery holder. Okay, so this is basically either you use a battery to power the circuit or you connect it to a power supply. And on here, you can see that there's what we call the springs. So these two springs are connected to each other, and these two springs are connected to each other. So each unit is basically, so each unit they are separate from each other. So in order to connect from one unit to another, you need a wire lead to connect those two units. Okay, and so and then this basically are the two banana jacks, and we have the potentiometer and also the place where we put the iron cord, and this is the inductor, which you're going to learn later, and this is where you put the light bulb. All right, so one of the things that before we use the resistor, or how to read off the numbers from the resistor, let's just look at the symbols often used in electrical circuits. So when you draw circuit, when you connect circuit with the various electronic components, you will use the symbol to in your drawing. So this indicate the wire. This is the indicate when you place a switch, and this is for battery, and this is for fuse, and this is for resistor, and this curl, this indicating inductor. And if you have the above that has two horizontal line, that's called that's inductor with the iron core inserted inside the inductor. And this two represent capacitor. And if you have a sign that say this is a positive here, it means that this capacitor comes with the polarity, and this is a positive sign of the capacitor. And this symbol indicates a light bulb, and this is the AC for AC power. And this G indicate you're using a galvanometer, and A here indicates the ammeter, and V indicates a voltmeter. So when you draw a circuit, before you connect your circuit, these are the symbols that you often use in your circuit. So one of the things that we want to learn is that we want to know, if you're given a resistor like this one with the color bands, what is the resistance value of this resistor? So each one has some has meanings. Take for example, okay. So and this table is the one that you would look it up in order to find the resistance value. So take for example, we have a resistor, okay. So a resistor with a green, blue, red, and gold bands. So how to read off the resistance value of this resistor? So to do that, we know that the first band is green. So that's located green. So green is 5. So this is the first band, and the second band has a color blue. So let's look at the blue. So the blue has 6. Okay, so you will read off the first two bands will give you 56. And the third one indicate a multiplier. So the third one is red. So red, if you read across, that is 100. So it's multiplied by 100. So the values here is 56 times 100 ohms. Ohm is a unit for resistance. And then the last color is gold. So the gold here, if we read across, that gives you the tolerance. So the tolerance or the uncertainty is plus or minus 5%. So your resistance, the resistance of this resistor that has a color band in this order, green, blue, red, gold, will have a resistance of 56 times 100 ohms plus or minus 5%, or you can say that it's 5,600 ohms plus or minus 5%. Okay, so this is basically how you read off the resistor, because a lot of time the resistance can actually read off from the color bands of the resistor. Okay, so moving on. Hold on, let me just get rid of. So the other thing that we want to learn is that how to use a digital voltmeter. So the multimeter usually have a panel that looks like this. Okay, and so this usually is on the top, and then this one is actually placed right here. So this is like multimeter that looks like this. Okay, all right. And so you can see that on this panel, it has several different functions. V indicate that this is where the range that you measure the voltage. So you can see that the range from 200 millivolt to 2V to 20V to 200V to above that. So in other words, when you want to use a voltmeter to measure voltage, you want to rotate this the range. You want to place the rotate the switch to place in the appropriate range. For example, if you want to measure something that's less than 20V, then that should be, you should place rotate this until you get to the 20, the 20 range. Okay, so that 20 is actually anything that's below 20 can be measured. And then if anything that's less than 2, then that you should place to this 2 here in order to get a better precision. And if something that's above 20, then you should place it between 20 and 200. Then this switch should be placed at 200 so that it can be so that the voltmeter can have a reading that is correct. Okay, so this is when you use that to measure voltage. And then if you want to use a voltmeter to measure currents, then you use current has a unit ampere. So that's A here. So it has 200 milliamp range. It also has 20 milliamp or 10 amp range. So you can see that when you rotate this rotate this dial to this position, the 200 the 20 milliamp or 10 amp range, it just means that it can either, depending on where you which socket that you plug it in, that you can it can either measure 20 milliamp range or 10 amp range. And then the F here is the one that you use to measure capacitance of a capacitor. And the ohms is the one that you use when this is placed in one of the range. You're using that to measure the resistance value. And then this H is for inductance. So you can see that for voltmeter, you can actually measure a lot of different quantities. And then in order to measure the quantities that you want, you just have to use the right range. Okay, and then on the voltmeter, there's a button that you can push in. When you push it in, then it measured AC circuit. If there's push out, it is used to measure DC circuit. Okay, so this is the button that really depends on what kind of circuit you worked on. You just have to remember to push in if you're using a AC circuit. Now for this experiment, we are dealing with DC circuit. So DC circuit is the button should be remain out. And then this one, as I mentioned, this one is usually placed below the dial. So here, this one, these two places basically if you have a capacitor, let's say capacitor looks like this and it has two leads. And then so usually you would just insert the leads into these two places, to get the reading. And then you change rotate the dial, to the Farad here. Now, to use this voltmeter to measure voltage, let's say you have some in a circuit and then it has two probes. And then let's say this is connected to the positive and this is connected to the negative. So your negative should be connected to the COM and the positive should be connected to this one. So this one is for, this plugin is for measuring voltage and the resistance, and the negative or the reference, the COM, should be plugged into COM. If you use the voltmeter to measure current, then this positive here, instead of plugging to this, the positive here should either plug into this place or to plug into this place, okay? Because if you plug into the MA range, then you're using 200 milliamp or 20 milliamp range. If the positive here is plugged into the 10 milliamp range, then you are when you rotate your dial to this place, then you're measuring the 10, you're using the 10 amp range. And so this is the thing that students often forgot to change. Let's say after they're done with measuring the voltage, they want to measure current. They still have this two leads plugged into this position and this place. You should remove this from here and then plug in either to this plugin or this plugin. Okay. All righty. So that is regarding how to use a voltmeter to measure various quantities. And let's see. Now to calculate error, as in physics 211, when you measure something, if you have the experimental value, if you have theoretical value, then to calculate the percent error, just basically find the difference, find the absolute value of the difference, and divide it by the value of the theoretical value and multiply that by 100%. That gives you percent error. Now, if you have if you are measuring something using two different approaches, you don't really know which one is more correct than the other. Then the base by convention, how do we calculate the percent error? Then you will use a larger value to minus you will subtract the smaller value from the larger value to find the difference, and then divide it by the larger value to get the percent error. Okay, all right. So for this experiment, there are two different parts. One part is the first part is that I scroll down to the data table. The first part is that you're given three different resistors. The color code will be given, and then based on the color code, you want to determine the coded value, and then you want to compare to the measure value in order to get the percent error. So that is your first part. And the second part is that you'll be given two resistors, and the two resistors, you're going to connect them either in series or in parallel, and then measure voltage and current in each configuration, and then find the theoretical value, and then compare those two values to get the percent error. Okay, so scrolling up, let's see how we do that. So like I said, you're given two resistors. You want to connect it in series or in parallel. So when you have two resistors, it's connected like figure 6. This is what we call a series connection. So this is a series circuit. Okay, what is the characteristic of a series circuit? You can see that. Let's say we output a 5-volt voltage, 5-volt voltage to the circuit when you have two resistors connected in series, and then you have the current that's coming out of the positive and it's going to complete the circuit and then coming back. You can see that this is how the current, the electron that moves in the circuit. Okay, so when you have a series circuit, whenever you have a series circuit, voltage will be different, but current stays the same. So in other words, if you use a voltmeter to measure the current through the first resistor, you're using the voltmeter to measure the current through the second resistor, and you measure the current through the whole circuit, you'll find that your I total is equal to I1 is equal to I2. In other words, current does not change. Okay. However, the voltage will change. And how do we calculate the voltage? You're going to measure it, and then you're going to find the theoretical for that. So to measure voltage, you basically just have a voltmeter, connecting across the voltage. Then you can measure the voltage. And then to calculate the voltage, then each voltage, first of all, you need to calculate the total current first. And then once you find out the total V equal to IR, this is the equation that you're going to use. Okay, V equals to IR. And whenever you have a subscript, that you have to be consistent. So your V total is equal to I total times R total. And then your VI, I is a rounding dummy variable. That's equal to II, the current, and then I can be 1, 2, and then you have the RI. Okay, your I is either 1 or 2. So in other words, your R1 is 100, your R2 is 330. You connect it in series. So you can see that when they are in series, that the common, there's just one point that connect one to the other. Okay, so you have the VI is equal to II times RI, and your RI can either be 100 or 330, and your I total is equal to I1 and I2. That's why you need to use this equation. Your V total is 5. Your I total can be calculated once you know the R total. And then once you calculate your I total, then you can use this equation to calculate your VI, individual VI. This is how you do it theoretically. Experimentally, of course, you're just going to use a voltmeter to measure voltage and current. And then with your measurements, you can compare to the theoretical value. Okay. Now, when you have two resistors, okay, by the way, so when you have a series circuit, what we found is that the R total, remember, you're going to calculate your I total based on this equation. You need to know how to calculate R total. So your R total for a series circuit, which you're going to learn in class, is that that's equal to R1 plus R2. Okay, so that's basically how you calculate R total for a series circuit. Now, when you have a parallel circuit, and when you have a parallel circuit like connected like this, so in other words, now there are 2 points connecting these 2 resistors instead of 1. Okay, and then so you have the resistor. This is your R1, this is your R2. You're still providing supply 5 volts to this circuit, and then you have the current that's coming out of this battery. And so the current coming in, so this is your I total, and this is your V total. And when the current comes in here, at this junction, you'll find that some current go through this upper one, and some current go through the lower one. So the one that go through the upper one, we call it I1, and the current that go through the lower one, we call it I2. So you have the I1, you have the I2, and the voltage will be, V1 and V2, we label that. And the current will continue to go, so the I1 will continue to go to this point, your I2 will continue to go to that point, and then they're going to merge. Once they merge at this point, when they come out, that's still your I total. Okay, so that's basically how the current, split and combined, so that so the whole thing still remain I total. So the characteristic of a parallel circuit is that your V total is the same value as your V1 and V2. So in other words, voltage for parallel circuits do not change. Okay, if this is 5 volt, your V2 is 5 volts, your V1 is 5 volts. However, your current would change. Your current basically is that the I total, your I total is the sum. Just based on this diagram, you can see your I total is I1 plus I2. Okay, so again, how do we theoretically, how do we calculate the I total? You will still use V total. V total is equal to I total times R total. You will still calculate your you will still calculate your I total first. But then if V total is 5, you need to know RT in order to calculate IT. And then once you calculate IT, and then you know that VT is equal to V1, V2, use V equals IR, V equals IR, so you can calculate individual currents, okay? And then to calculate, and then I total is I1 plus I2. You need to calculate RT. So RT is basically let's just write, okay, RT, let me write here. So your 1 over RT. So RT is equal to 1 over RT is equal to 1 over R1 plus 1 over R2. Okay, and you know the R1 and R2, so when you plug those in and then get into a calculator, and then remember to take the inverse of that in order to get your RT. Once you have your RT, then from this equation you can calculate your IT. Okay, and then from V equal to IR, you can calculate, and then V is V is the same, so you can actually calculate IT. If you calculate I1 and I2, using V equals IR, that will work as well. Okay, alrighty. So this basically, so the main thing is that for series circuits, this is how we calculate resistance of the circuit, and then this is the current. Current stays the same. Voltage will be different. And for parallel circuit, voltage stays the same, current will be different. And this is the equation to calculate the R, okay? And so, hold on. So, let me see what else. So you would, you have the data to work with, and you're going to follow the steps in the analysis in order to calculate the various quantities and then complete the circuit. Now let's look at how we set up the circuit. Like I said, in order to calculate, in order to measure voltage or the resistance, you would let's say you will use a voltmeter, and then you had 2 leads, and then each lead is going each lead has a banana jacks that clip on the alligator clips click on the lead of the resistors. So this will give you the reading. So when you measure resistance, whenever you measure resistance of a resistor, do not connect the resistor to a power supply. Okay, you only need to so in other words, if you have, let's say, if this is a resistor and you want to measure the resistance, so this is the voltmeter. You change the dial, and then this is the leads, and then it has alligator clips. So one is connected to this, and the other one is connected to that, and then that will give you the resistance value. Now, for circuit, so you can see that when I measure the resistance, it does not. You do not connect your resistor to a power. That's why when you connect your circuit, once you connect your circuit, you do not power the circuit just yet before you measure the resistance. You want to measure the resistance and then turn on the power supply to power the circuit. Okay, all right. And the other things is that, let me see, how to connect your how to measure voltage. Whenever you want to measure voltage of a resistor, let's say in part of the circuit, then this is the resistor, and you want to measure the voltage, then you have the positive that's coming out of here, just connected to the lead, one lead of the resistor, and then the COM is connected to the another lead of the resistor, and then the whole thing is actually connected to a power supply. Let's say this is a power supply. It is connected to the circuit. So then you can measure what is the voltage across this resistor. So just across, just like this. Okay. Now, when you want to measure current, you want to insert an emitter in the circuit. So you need to break the circuit. So you can see that here we actually take this resistor out of the spring, and then so this become like is a way it is not connected to the spring, and then you will have like the positive. Here is the positive, the emitter that is connected to this one lead, okay, and then the other one is connected to this, so that you can see that when the current go through the circuit, it goes, let's say this, the current go through the power supply, coming to the spring, going through the ammeter, and then follow this curve. It go through this this lead of the resistor, and then come across that, and then complete the circuit like this. Okay, so whenever you want to use the ammeter to as a you want to use a voltmeter as an ammeter, or if you have an ammeter, you just have to break the circuit and insert the ammeter in the circuit, so that your ammeter becomes part of. So you can see that it becomes part of the circuit. Now for voltmeter, you can see that it is kind of independent of the circuit. It's actually just clip on the leads. Okay, so how do we connect the circuit? So let's say you're given for series circuit, for example, you have something like this, and then how do we connect it to the electronic board? So using this board as an example, so for series circuit, let's say we put one resistor here, and then we put another resistors here, okay? And then these two are independent, so we need one wire lead to here, and then one wire lead here, one wire lead here, and then this connected to, and this will be connected to the power supply, okay? All right. So you can see the current go through here, and then come here, and then go through this unit, and then through the resistor, through the wire lead, go through this second resistor, through the wire lead, and then complete the circuit. So this is how you connect the circuit like this. Okay. Now to measure voltage. So let's say I want to measure voltage. So I have a voltmeter here. To measure voltage, this is my positive. So my positive should be connected to positive, and then the comp here, that's connected to the other end. Okay, and then if I want to measure voltage of this side is more positive, so my positive will clip on this any place within this two spring, and my con will connect to this spring. Okay, to measure total, I will connect my positive connect to positive, my negative connect to negative. Okay, to measure current, you need to break the circuit. So I will break it. If I want to measure current I1, I will break it. So my resistor will now becomes like this. So I remove one lead from off here. So this is my ammeter, and my positive will be connected to the spring, anywhere within the spring, and my negative will connect to where I took the lead off. Okay, so you can see that this becomes part of the circuit. Now, if I want to measure the current through the second resistor, I will remove this lead from this side. So let's say if I take it off here, and this is my resistor, this is the free end. So this is my ammeter. And so my positive of ammeter will be connected to here, and my negative, the reference, the comp, will be connected to here in order to measure current. To measure total, you can, to measure total, this is the wire lead, so you can remove this wire lead. So the wire lead becomes like this. So this remove wire lead from this side, and your ampere. So you would have the positive that is connected to where you just took the lead off, and the negative is connected to the free end here. Okay, so that becomes part of the circuit. So that's basically how you connect your circuit for this is for the series circuit to have the the parallel circuit. You will have like one resistor is here, and one resistor remains here, and then two circuits. So you have one wire lead here, let's see, so, and then one wire lead here, and then and then one wire lead here. So you have one that's So the current coming here, it can go from here, this point or that point, and then you might have one wire lead from this point, this spring, all the way up to here. Okay, so this is a one junction here, and this is another junction, and then come back here. Okay, you don't have a wire lead here, because then you will short the circuit. So that's basically how you connect the circuit. And then if you look at the appendix, it actually show you how to measure voltage and current at the same time. For example, if you want to measure V1, this is your R1, this is your R2. How to connect the circuit, how to use the voltmeter and ammeter simultaneously. You can just follow the diagram to get a better understanding how to do that. Okay. Now regarding table, let me just bring up the table. For the table, the one you're going to have, let me see which one is this. Table data, yeah. So the table that you're given, so these are the color code. So you need to convert, check, look up the table and look at the color code, and the measure values are already given. So you just compare these two to get your percent error. You will use the coded value as a theoretical, okay? And then for the two resistors in series or two resistors in parallel, so you have the 100, 300, 330. You need to use follow the steps in the analysis to find out the total, and then the experimental values are all given. Follow the steps in the analysis to the calculations, and also to find the percent error, and that will complete your data analysis. And of course, when you do the simple calculation, you need to show me how to calculate R total for the two resistors in series, and how to calculate R total for two resistors in parallel. And you just need to show me V equal for the V equals IR, that equation. You just need to show me one equation, how you calculate how you use that equation to calculate either voltage or currents, for the series and for the parallel. Okay, so that's basically what you want to do.